The first problem that we have requires that we use a calculator or otherwise in simplifying this expression. Well, it is better to use a calculator because other would not be wise in this case. So use a calculator or otherwise. So we are opting to use the calculator, and I'm suggesting that you use the calculator also. So we will perform the multiplication and find the square root of 0.624. So we will perform this multiplication, put the answer down, and add the result to the square root of 0.624. So there we have 3.9 multiplied by 0.27, and that is equal to 1.053. That we will add to the square root of 0.624, which is 0.82, and that is our answer. We will express this one as a single fraction. We will convert 2.5 to an improper fraction and use the division sign in adjusting the position of 3/4. So convert the 2.5 to an improper fraction and use the division sign in adjusting the position of the 3/4 that we have right here. So we will convert this to an improper fraction. 2 times 2 is 4 plus 1 is 5. So that will be 5/2. And we will not draw another line here and write 3/4 as a denominator. This line that we have here means that all that we have here will be divided by 3/4. So we may use the division sign to say all of what we have here will be divided by 3/4. We have the improper fraction representation of 2.5 right here, and we have enclosed the expression that we have in this large numerator. We have enclosed that expression in brackets. Without the brackets, the expression would have been a false representation of the original problem. That is because without the bracket, we are going to apply our laws of precedence of operation. And we know that division will take precedence over subtraction. So without the bracket, we will mean that we are going to be dividing the 4/5 by 3/4 before subtracting the entire result from 5/2. But the brackets here, when we have brackets, the contents of the brackets will take precedence. So we will perform the operations that are inside of the brackets first. So we are taking a common denominator for 2 and 5 in order to add these fractions. And of course, the most appropriate common denominator is the LCM of the two denominators. So we say 2 into 10 is 5, and 5 times 5 is 25. The negative sign goes back, and we say 5 into 10 is 2, and 2 4s 8. Here we are dividing by 3/4. The equivalent operation to dividing by 3/4 would be to change the division sign to multiplication and also do the reciprocal of the fraction. So let's do that. So in dividing by 3/4, we multiply by its inverse. (25 minus 8 is 17). So we have 17/10 multiplied by 4/3. We have common factors for 4 and 10, so the fraction may be reduced by a common factor of 2. Eventually, we will have 17 times 2 34, and 5 times 3, 15. And our answer will be 34 over 15. This problem involves a rate of exchange between two countries. We are therefore dealing with foreign exchange. In solving this problem, we may use a table as a guide. It is not completely necessary to use the table, but it helps to give some order or form to the calculation process. The first thing that we'll introduce in the table is the rate of exchange. So we have $1 Canadian to $72.50 Jamaican. We have the amount in Canadian currency, and we need to convert that to the Jamaican currency. According to the rate in the table, of course, the first row in the table is a representation of the rate of exchange. As we can see, the number that we have on the Canadian side, $1, is smaller than the number that we have on the Jamaican side. We may say also that the number that we have on the Jamaican side, which is this figure, 72.5, is larger than the figure that we have on this side. Therefore, in converting from Canadian to Jamaican, the figure that we get on the right hand side of the table, which is on the Jamaican side, has to be larger if we want to be consistent with the information in the table. So we have to have a larger figure when we do the conversion, a larger figure on the Jamaican side. So we will therefore multiply by the rate of exchange. 250 multiplied by 72.5, and the result is 18,125 Jamaican dollars. $18,125 was spent out of the $30,000 that he has for his credit card limit. So what is the remainder? All we do is just do a subtraction. So we subtract 18,125 from 30,000, and the result is $11,875. The figure that we have just calculated will be converted to Canadian dollars, and we are going to be using the table, and of course we are going to be using the same rate of exchange. And the amount in Jamaican dollars, the same figure that we have just calculated, will be on the Jamaican side. And according to the rate, the figure that we have on the left hand side is smaller. So if we are going to be converting from Jamaican currency to Canadian currency, the figure that we have on this side is going to be smaller. Therefore, we will have to divide by the rate of exchange that we have right there, 72.5. So 11,875, we divide that by 72.5, and the result is 163.79 or $163.79 Canadian. Right here we have A is equal to 2, B is equal to -1, and C is equal to 3. We are required to find the value of A times the sum of B plus C, or A times all of B plus C. What we will do first is make a template in the form of the algebraic expression, and then we will insert the values in their respective places and simplify the result. So we will have what? A, we have this slot for A, we have a slot for B, empty space for C. So we are going to put the value of A right there. The value of A is 2, the value of B is -1, and the value of C is 3. Then we will have -1 plus 3, and that is equal to 2. So we will have 2 times 2, and that is equal to 4. We have a similar situation here, but the expression that we will substitute into is a little bit heavier than the one that we had before. We put a template like we had before. We leave our slot for B right here, and of course the square is there just as we have it, and 2, and we have the slot for A, the slot for C, and so on. So let us insert the values in their respective places and simplify the result. So the 2 will go there. Of course, we are going to put in the values of A first. Then we put in the values of B where they belong. And then of course we have 2 values of C also. 2 slots for C also. Simplification gives, of course, -1 squared is +1. So we'll have 4 times 1. And of course, -2 times 2 times 3, that is -12. And of course, 2 plus -1 plus 3, we may say 2 plus 3 is 5, minus 1 is 4. And that is what we have right there. So 4 minus 12 is -8. So we will have -8 to be divided by 4, and the result is -2. We will convert 2 regular statements to their algebraic representations. 4 times the sum of x and 5. Write down the sum of x and 5. If we will find 4 times the result, we will multiply it, which is this result, by 4. It is appropriate to enclose the result in brackets, and the multiplication sign is not necessary. So that is 4 times the sum of x and 5. (16) larger than the product of A and B. 16 larger than the product of A and B. So write down the product of A and B, which is of course AB. 16 larger means an additional 16. So we are just going to add 16 to the result, and that's all there is to it. We will then solve this linear equation. First, we will expand the brackets that we have on the right hand side. We have brackets on the right hand side. We will do our expansion. 2 times 3x is 6x, and 2 times 1 is 2. In order that the coefficient of x will be positive, we will transpose the x's to the right hand side and the constants to the left hand side. So if we transpose this 6x to this side, the x's will turn out to be negative. It is not impossible to solve the equation with that, because we have done extensive work with positive and negative numbers in Volume 1 of Richard James Mathematics Resources, which is algebra. So we are not fearful of manipulating negatives, but if we can avoid them, we will just do that. So we will transpose this -4 to the right hand side, and of course this constant value will be transposed to the left hand side. So there we have 13 is equal to 10x. X is equal to 13 over 10, or we may write that as 1.3. Now we will factorize the expression that we have right there on the screen. Write down the common factor. Of course, we are going to take the highest number that can go into 6 and 12. And the highest number that can go into 6 and 12 is 6. Of course, the highest power that can go into a squared and a to the power of 4, which is of course a squared. Do not forget that when we are manipulating indices, if we are dividing, we are going to subtract the indices. So we are saying what is the largest number that can be subtracted from 2 and 4, and that largest number that can be subtracted from 2 and 4 is 2. We will go to the b's and we will say the same thing. What is the largest power of b that can go into b cubed and b? Of course, b is b to the power of 1. The largest power of b that can go into b cubed and b is b to the first power, or just b. We will then divide each term by the common factor. Of course, first term, which is this one, the 6 will cancel right here. A squared will also be cancelled, and b into b to the power of 3. Do not forget that when we are dividing, we subtract the indices. So we will say then 3, and the default index, which is 1, is the power of b right here. So we are going to say 3 minus 1, which is 2. So we'll get just b to the power of 2, or b squared. Here we have 6 into 12 is 2. A squared into a to the power of 4. We subtract the indices and we get a to the power of 2, and b into b is 1. But we do not need to say a squared 1 or a squared multiplied by 1, because anything multiplied by 1 is that same thing, so we can treat it as if the b is cancelled completely. Here we have our favorite trinomial. We will find the two numbers whose product is 2 times negative 5, which is of course negative 10, and whose sum is positive 9. Those two numbers are a positive 10 and a negative 1, and those numbers will be the coefficients of the two middle terms. So we have 2m squared plus 10m minus 1m, or just minus m, minus 5. We will do our factorization by grouping by taking these two and say what is the common factor in this case. Of course, 2 will go into 10 and 2, and m will go into m squared and m. So 2m is going to be the factor right there. 2m into 2m squared is m, and 2m into 10m is 5. With no blatant or obvious common factor right here, we will choose a negative 1 as our common factor. Well, as a matter of fact, we will choose 1, but we generally use the sign of the coefficient of the number that begins the second pair. So we are going to use, in the second pair, we are going to use the sign of the first term, which is negative. And of course, we have no obvious common factor, so we choose 1. And negative into negative is positive. Any number divided by 1 is the same number. And of course, negative into negative is positive. And 5 divided by 1 is 5. No doubt, the common factor is m plus 5. And in the other bracket, we will have 2m minus 1. I cannot remember seeing a pie chart in the CSEC CSEC examination since at least not the long paper, not paper 2, since I've been looking at it in 1989. So from 1989 I have never seen a pie chart. But we have one in this particular case. At a career guidance seminar, a survey was done to find out the type of careers that Form 5 students were likely to choose. The results are shown in a table, and of course we have the table in the question booklet. There were 1,080 students surveyed. We are required to calculate the value of T, which is the number of students who were interested in becoming a doctor. The fact is, of the 1,080, the number that is missing is those who wanted to become, the number of those who wanted to become doctors. We therefore will subtract all of the other values from 1,080, and we will get the number of those interested in becoming a doctor. So we have the total of 1,080. Only one value is missing. Find that value by subtracting all of the known values from the total. So we have subtracted all of the known values from the total. Those who are interested in becoming a doctor is 105. To find the angle associated with each, we need to multiply the relevant fraction of the pi by the angle of one revolution. To find the angle associated with each, we need to multiply the relevant fraction of the pi by the angle of one revolution. So we are going to construct the pie chart, but in order to construct the pie chart, we need to determine the angle that is associated with each career. In order to do that, we need to find the fraction associated with each career and multiply that result by the entire angle of one revolution. Now, the fraction associated with each will be the number of each divided by the total. Like we have for a lawyer, we have 240 interested in becoming a lawyer. We divide that by the total of 1,080 and we multiply the result by 360 and we get 80 degrees. We have how many interested in becoming a teacher? 189. So we do 189 divided by 1,080 and we multiply that result by 360. We have 63 degrees. We do the same for doctor. Remember, we calculated it just now. 105 to be divided by 1,080 and we multiply that by 360. 35 degrees. Artist, 216 to be divided by 180 and that's 72 degrees. And for a salesperson, we have 110 degrees. We will no doubt put the information in the pie chart, marking or indicating or designating the appropriate sector in terms of its actual size to each career. So let us do that. We will first draw an initial line. So that is our initial line. Draw an initial line. What do we do next? Place the center of the protractor at the center of the circle and the zero line on the initial line. So the protractor will be placed with the zero line of the protractor on the initial line. The center of the protractor being at the center of the circle, and of course we are going to take note of the 80 degrees. After taking note of the 80 degrees, we put a mark right there where 80 degrees will be. Right there. Then we use our ruler and draw the line. So we have completed the sector and that one belongs to the lawyer. Next, we will use the new line that we have just drawn as the initial line for the protractor. So we'll have the protractor, the zero line of the protractor on that line, and we will take note of where 63 degrees will be, and we will use our ruler to complete the sector, and that one will be designated to the teacher. Do the same for 35 degrees. The new line that we have is the zero line. Put the protractor with the zero line on that line, the center of the protractor at the center of the circle. Mark off the 35 degrees. Complete. Next, we move on to the artist. We will use that new line as our zero line with the center of the protractor at the center of the circle, and the 72 degrees will be about right here, we think. Alright, let's see. I think it's about right there, past 70, and go a little bit more. So 72 degrees will be right there. Correct. Then we will use our ruler to complete the sector, and that one will be for the artist. Now we do not need to measure. Hopefully we would have completed the sectors that we have done correctly, so that the other one will be 110 degrees and it will belong to the salesperson, and the pie chart would have been completed. We have a problem of set theory. We have a universal set with the elements of the universal sets given there. M is the set of prime numbers, and N is the set of even numbers. So we have what? The set of prime numbers and the set of even numbers. Those will be the sets in the universal set. The only even number that is a prime number is 2. The universal set begins at 15. Therefore, we will not have any prime number that is even in that set. The sets of prime numbers and even numbers will have no element in common. The sets will be disjoint. It is disjoint because we are starting at 15. We are not starting at 1 or 2, in which we know that 2 is an even prime number. So 2 is not going to be in any one of those sets. So we are sure that since 2 is not involved, the two sets will be disjoint. And our first number is 15. And 15 is not even, it is not prime, it is going to be in the universal set, not in any of those sets. 16 is even, so we'll put it in the set on the right. 17 is a prime number, it will be placed in the set of prime numbers, naturally. And 18 is even, takes its place right there. 19 is also a prime number. What about 20? Even. Is 21 a prime number? No. 3 and 7 will go into 21 without leaving a remainder. 21 is not a prime number, and it is not even. It will be placed right there. What about 22 is even? Yes. 23, that's another prime number. Goes in the set of prime numbers. 24, even, and 25 is not a prime number, and it is not even. It will be placed in the Venn diagram, but not in any of the sets that we have right there. We are required now to list the elements of the set M union N, all complement. And of course, complement means what? Those elements that are not in this set that we are complementing. So we are complementing the set that is M union N. The best interpretation of this problem is that we need the complement of the union of the two sets. This will be the elements outside of the union of the two sets. So we block those two sets out, and those elements are outside of the union. Those will form the set of elements in M union N, all complement. And do not forget that when we are talking about set theory, the result is usually another set, except in the case that we are required to give a number of elements in a set. So the result is usually another set, and we need to enclose them in those brackets to indicate that they constitute another set. Using only a pair of compasses, a ruler and a pencil, construct a parallelogram ABCD in which AB is equal to AD is equal to 7 centimeters and the angle BAD is 60 degrees. So we are going to draw the line AB, which is 7 centimeters. Oh, that is our ruler, and we are just going to use 7 centimeters. Next, we are going to construct, we have what? That's AB. Right. That's AB. Good. So, the angle BAD is 60 degrees. The middle letter is always the vertex at which the angle is located. So, the angle is located at A. We will construct the 60 degrees angle at A. What do? We put the point of the compass at A and we make two arcs, one like that and the other to cross the line AB. Where the first arc crosses the line AB, what do? Put the compass point there, and without adjusting the pair of compasses, we will draw another arc. So we will put the compass, the point of the compass, where the arc crosses the line AB, and we will make another arc. Then, of course, we are on our way to drawing or to completing our 60 degrees angle. But AD must also be 7 centimeters. So we are going to use our ruler and we are going to draw the line to 7 centimeters. The angle that we have just constructed is BAD. We have the points A and B already. The point at the other end of the line that we have just drawn is therefore the point D. Next, we are going to construct the line that passes through D and is parallel to and equal in length to AB. So, we are going to construct a line that goes through D like this and is parallel and equal in length to this line, AB. And we are going to, no doubt, use construct number 8. Construct number 8 is in Richard James Mathematics Resources, Computations Part 2 and Geometry. But we will just give a brief summary of it right here, while at the same time constructing the parallelogram. So, open the pair of compasses with the point at A and the point of the pencil at D. Then place the point of the compass at B and make an arc. So open the compass, the pair of compasses, so that we have the point of the compass is at A and the pencil is at B. Then move the compass to B and make an arc. That is without adjusting the pair of compasses. So open the pair of compasses with the pencil at D and the point of the compass at A. Move the point of the compass to B and make an arc. That is without adjusting the compass, without adjusting the pair of compasses. Next, open the pair of compasses with the point at A and the point of the pencil at B. Then, without adjustment, place the point of the compass at D and make an arc. Open from A to B, put the point of the compass at D, then make an arc without adjusting the pair of compasses, right? And that is going to be our point C. The point of the intersection of the arcs will be the final vertex C. The parallelogram may be completed by drawing the lines CD and BD. That is our point C, and we have CD and CB or BC. We could have constructed the parallelogram by constructing another 60 degrees over on this side. So we'll have 60 degrees here, another 60 degrees on this side, and when we draw this up to 7, we complete the parallelogram like that. So that could have been another way. Use the ruler to measure the distance from A to C. And by the looks of it, it is a little bit or a wee bit past 12 centimeters. So it's around about 12.1 centimeters. AC is equal to 12.1 centimeters. Now we are going to have a lot of fun. The diagram represents the plan of a floor. The broken line RS divides the floor into two rectangles A and B, as we can see. We are going to calculate the length of RS, and we are going to state the value of X. So let's go. RS is related to the dimension of 8 centimeters. The relationship is obvious. Let us show it more closely. So we know that RS is related to the dimension of 8 centimeters. So let us look at that. RS, see what happens? Right. RS and the 2 centimeters that we have there together will be 8 centimeters. So RS plus 2 is equal to 8. Of course, just by looking here, if this is equal to 8 and this part is 2, then of course, no doubt, this is 6. So RS plus 2 is equal to 8. RS is equal to 8 minus 2, which is equal to 6 centimeters. And of course, the next one say, write down the value of X. The problem said write down, so we should be able to determine the answer by sight. So we should be able to just look at it and know. Say we have 10 here, and we have X here, and know that the 10 goes all the way across here, and this goes all the way across here. And because we know the length of RS already to be 6 centimeters, we have no problem figuring out that X has to be 4. But let's see if we can cause it to just appear more obvious. Right. So the 10 and what we have there. So we have 6 there, and the rest is X, and the total is 10. So X is equal to 4 centimeters. Hence, calculate the perimeter of the floor. So let us calculate the perimeter. The perimeter is the entire distance around the figure. This is equal to the sum of the sides. So we will add the sides as we go around the figure. We will be pointing that out in great detail. P is the perimeter, and that is equal to, that dimension is 10. Right. Notice that one is opposite to the 5 that we have on this side, and of course it is therefore 5. The next one is obviously 2. We have 2 centimeters right there for it. The other one is 3 centimeters. Then we have a total of 8 centimeters, and of course that one is opposite to the 3 centimeters that we have here, so it is also 3 centimeters. And X we calculated to be 4 centimeters, and that one is 5 centimeters. We have a total of 40 centimeters. Section A of the floor is to be covered with flooring board measuring 1 meter by 20 centimeter. How many flooring boards are needed for covering section A? In order to find the area, the shape may be conveniently divided into two rectangles. So, the area, we are calculating the area of the entire floor first. So, as a matter of fact, that was required of the statement of the problem, that we calculate the area of the entire floor first. So, let's do that. The area is equal to, the first part, A, is 10 by 5. So, that's 10 by 5. And the other part, B, is 3 by 8 or 8 by 3. Right. So we have 5 tenths 50 and 8 threes 24. 50 plus 24 is 74. So that's 74 centimeters squared. And the flooring board now will be required to cover section A. The area of section A is 50 centimeters squared. The only twist to this problem is the 20 centimeters in the shorter dimension of the flooring board. With 100 centimeters equal 1 meter, dividing 20 by 100, we get 0.2 meters. So, the 20 centimeters will be equal to 0.2 meters. And that is what we're going to use to determine the area of the flooring board. So, the area of section A is 50 centimeters squared. And the area of the flooring board will be 1 multiplied by 0.2, which is 0.2 meters squared. So to find the total number of boards, we will divide the area of the section by the area of each board. So 50 divided by 0.2 is equal to 250. In the diagram, GH is a vertical pole standing on horizontal plane, and HJ and K are points on the horizontal plane. And of course, no doubt, we know that the vertical and the horizontal are right angles to each other. Therefore, the triangles that we are going to be working with are going to be right-angled triangles. So do not worry about where the problem says the angles of elevation are from. The size of the angle must match. So of course we have what? 32 degrees and 27 degrees are the angles of elevation. So we don't have to worry which is which. We know that this is the smaller angle. So this is the smaller one. So that has to be 27 degrees. This is a larger angle. So it has to be 32 degrees. No problem whatsoever. We need to determine first the length of HJ. HJ, and we are going to be using that triangle in order to calculate HJ. We have HJ here. We have this triangle with 32 degrees there. So we are going to be using this right angle triangle. In this right angle triangle, this side, which is the known side, relative to the angle is opposite, and HJ is adjacent. Which trig ratio contains opposite and adjacent? Of course, tangent. So the tangent of 32 is opposite over adjacent. So it's 12 divided by HJ. By transposition, if we are dividing by HJ on this side, we will multiply by HJ on that side. So HJ tan 32 is equal to 12. But do not forget, we are finding HJ. HJ will be found by dividing 12 by tan 32. As a matter of fact, the relationship between HJ and tan 32 is multiplication. Therefore, we will divide by tan 32 on the right hand side. So HJ over tan Hj is equal to 12 divided by tan 32, and that is 19.2 meters. Then we are required to find Jk, which is this one, Jk. By looking at this, some people start to think, how are we going to do that? Well, Jk cannot be calculated directly. We need to find Hk first by making use of the other right angle triangle. So there is our other right angle triangle, and we are going to find the total distance all the way from H to K. And of course, what do we know? The calculation that we made just now for the previous right angle triangle is analogous to the one that we are going to be making right now. So instead of going through all the process, tan 27 is equal to 12 over HK and all of the rest of it, we know what is going to happen very quickly. We are going to have HK is equal to 12 over tan 27. And that is what we do very quickly. HK is equal to 12 over tan 27, and that is equal to 23.6 meters. From our experience on the previous slide, not that we needed that experience, but we saw it happening on the previous slide, we need to find Jk. So Jk is going to be the difference between Hj and Hk. And the difference will be 4.4 meters. The figure P undergoes a transformation in such a way that the image is Q. Describe the transformation completely. The object shows no rotation and no change in orientation. The transformation is a translation. Because this is what we have as the image, it looks exactly like the original, but it is only located at another position. So we are sure that the transformation is a translation. Now we are going to pick a point on the original object and see how it is related, or the movement that we will cause it to undergo in order to get to its image on the figure Q. So take note of the movement of a point on P in order to get to its image on Q. So we have it right there. We first go along the positive direction by 2 units, and then we go down. So we are going to go in the negative y direction by 7. Let's see if it is 7. 1, 2, 3, 4, 5, 6, 7. By 7 units. So the transformation is a translation by the vector to -7. Next, we will draw the line y is equal to x. How do we know that line? The line y is equal to x passes through all of the points whose x and y coordinates are equal. Okay, so it will pass through 2, 2, it will pass through 4, 4, it will pass through 6, 6, it will pass through 8, 8, it will pass through -2, -2, and so on. So the x and y coordinates of all the points on that line are equal to each other. Next, we are going to find S, the image of P under a reflection in the line y is equal to x. Each image point will be located 90 degrees across the mirror line by the same distance as the original. Like in the case of a typical mirror, the point on the mirror line and its image will be located at the same spot. So we are going to say, if we are going to find the image of this point, what do? We go 90 degrees across by the same distance that we have on this side, across like that, and that is where the image is going to be. Now for this point, because it is on the mirror line, its image will also be on the mirror line. This one, we go 90 degrees to the mirror line and we'll go the same distance across. The other one will be done in the same manner, 90 degrees across by the same distance. Notice that we have one diagonal of the little square, one diagonal of the little square. Notice from here we have 1, 2 and a half diagonals of the little square. We have a half, then we have 1 and a 2. So we make sure that we have the same distance across the mirror line. And of course, this line needs to be perpendicular to the mirror line, the line that will join the point to its image. Now we are using these lines to demonstrate. If we are going to be using construction lines, we will have to use pale construction lines, as in volume 5 of Richard James Mathematics Resources. So complete the figure, and that is the figure that we are looking for. We are going to be making use of the equation of a straight line, and we have a straight line there already, so we are going to use the information that we have on that graph to answer the rest of the problem. The equation of a line above is y is equal to mx plus c. So we have the typical equation of a straight line, y is equal to mx plus c. Now we need to state the value of c. C is a constant, and it is equal to the position where the line crosses the y-axis. It crosses the y-axis at 1, 2, 3, 4, 5, 6, 7. So it crosses the y-axis at 7. So c is equal to 7. And we are going to determine the value of m. Now when we have a graph, we may choose 2 points and use y minus y1, use y2 minus y1 over x2 minus x1. That's a formula that we always use to determine the gradient. However, because we have a graph, we do not have to go that route. We are going to move from A to B, and of course the y movement will be noted first, then the x movement, because remember that it is the y difference, or the y movement, or the change in y over the change in x. So we'll put the y movement first. To state the value of m means that we should not have to calculate it. So we will just find 2 convenient points on the line and take note of the movements in the x and y directions between the 2 points. So m is equal to, what do we have for the y movement? Going down 1, 2, 3, 4, 5, 6, 7. So that's a negative 7. And we go across by 2. 1, 2. So negative 7 over 2. And that is our gradient. The midpoint, do not forget that when we are calculating midpoint, we just always say that it is the average, halfway between the two of them. So we add both ordinates, the x ordinates of the 2 points, and we divide by 2, and we do that for the y ordinates also. So we have A is 0, 7, and B is 2, 0. So we have 0 plus 2 divided by 2 and 7 plus 0 divided by 2, and the result is the midpoint 1, 3.5, or 1, 3.5, Some might still want to write it as an improper fraction. 1 7 over 2. Now we have this statement that says that the point negative 2k lies on the line, and we need to determine the value of k. There are a few ways that we may solve this problem. Let us use a method that is based on the equation of the line. We have y is equal to mx plus c. We already know the gradient m and the y-intercept. So substitute them in the appropriate places. So first, our intention is to write down the equation of the line. The general form is y is equal to mx plus c. Y is equal to mx plus c. M we know is the gradient, and that is negative 7 over 2. And c is the constant, which is 7. So we know that y is equal to negative 7 over 2x plus 7 is the equation of the line. The gradient we determined already as negative 7 over 2, and the constant is 7. Y is equal to the gradient plus the constant, or the y-intercept. So y is equal to negative 7 over 2x plus 7. And we have the point negative 2k that is on that line, and we need to determine the value of k. So in that equation, we will substitute the x and y values of the point negative 2k into the equation. So where we see x, we put negative 2. Where we see y, we put k. Then we are going to, I think this is a little bit drastic, so let us take a second look at it. Now we have negative 2 here, and we have a negative sign here. Negative multiplied by negative is positive. And of course the 2 will cancel. So we will have a positive 7 here, and here we have a positive 7. So k is going to be equal to 7 plus 7, which is equal to 14. We need to find now the point of intersection of the line y is equal to x minus 2 and the line that we have. So we have y is equal to negative 7 over 2x plus 7. We need to find the intersection of this line and another line. Y is equal to x minus 2. So if y is equal to negative 7 over 2x plus 7, and y is equal to x minus 2, then x minus 2 is equal to negative 7 over 2x plus 7. Both equations are in the form y is equal to. Therefore, the two right hand side must be equal, and we have equated them right here, so we just need to solve this equation for x. First we will multiply through the entire equation. We will multiply through the entire equation by 2. And that is the result. 2 times x, 2 times negative 2, 2 times negative 7x over 2. Of course, the 2's will cancel in this particular case. And 2 times 7 is 14. Then, of course, we will transpose this negative 7 to the left hand side. 7 plus 2 is equal to 9. So we have 9x. Then we have this to be transposed to the other side. 14 plus 4 is 18. So 9x is equal to 18. 18 divided by 9 is 2. Place the result in any of the equations of straight line. So we have two equations of straight line. One is not on this slide. The other one is y is equal to negative 7 over 2x plus 7. And the other one is y is equal to x minus 2. So we're going to put that value into x minus 2. So we have y is equal to 2 minus 2, because y is equal to x minus 2, and our value of x in this particular case is 2. So y is equal to 2 minus 2, which is equal to 0. So the coordinates of the point where the two lines will cross is 2, 0. Some other students might want to sketch the line on the same graph and look where the two lines cross each other, and that is a possibility. We cannot rule out or turn a blind eye on.